Hello. In this video, we're going to just introduce you to the ideas of the quiz tree material that consists of two submodules. 1.5 that is about reducing matrices and 1.6 which is about consistent systems. So for 1.5, the idea that I want you to have in mind while you're reading your textbook is about the relationship between matrices and systems of equations. So you usually start with a system of equations, and of course, linear equations. And from that, you can get an augmented matrix and from there what you're going to do is you're going to use basically the same ideas as your Gauss-Jordan procedure to lead this augmented matrix into what we call the reduced echelon form. Your textbook will have several examples about what is this reduced echelon form and the relationship between this reduced echelon form and your system of equations is that once that you get to this, reading what are the solutions for this is going to be easy, and that's going to actually tell you what would it be the solutions for your system of equations, the original one. Okay, so you want to pay attention to this definition of what is a reduced echelon form. Look at a lot of examples that you have there because they do tell you a lot about what is this about. And it does take time to get used to the idea of is this reduced or is it not? And that's, of course, the type of questions that you should expect for your quiz. They will give you a matrix and an augmented matrix, and they would ask you if it's in its reduced echelon form. About 1.6, remember that a consistent system means that it will have at least one solution. But it could have infinitely many solutions. And one of the things that I want you to keep in mind is like there is no in between. Either you do have one solution or you have infinitely many solutions. If you have two solutions, you can find linear combinations of those and you can have infinitely many solutions. So a consistent system has only two choices. It has one solution or infinitely many, and the other option is that it's inconsistent, and that means that there are no solutions for that system of equations. And about this, one of the things that I want you to think about is, okay, let's try to connect this idea with your reduced echelon form. So let me just give you an example. Suppose that you have, say, three variables. So let me call my variables x1, x2, and x3. And then this is my column for the constants. So we got that with the b's, b1, b2, and b3. B's. And then I'm going to have, say, I'm trying to reduce that, and I reduce it, and I have it something like this. And suppose that I started with two equations, so I get something like this. The first question for you is this in a reduced echelon form? Yes or no? Well, you have a 1, you have a 0 underneath, and that's it. then you go to the diagonal, you have a 1 here, 0 everywhere else, so far so good. And then you cannot do much more about this. So this one is actually in its reduced echelon form. And that means that out of this, I can see what would happen with my solutions. So my solutions are telling me that reading out of this, 1 times x1 is equal to c1, so x1 equals to c1, then x2, 1 times x2, plus 7x3 equals to c2. And if you see from here, I could solve for x2 in terms of x3, or I could solve for x3 in terms of x2. But I cannot find specifics about any of these two. So what I can do is, let me just do that, solve for x2. Just put it this way. Negative 7x3 plus c2. And that tells me that if I can make x3 into any value, so we substitute, we call this like any value s. For any value s that I have here, that tells me the value of x2, and the value of x1 is already determined. So this is an example of a system of equations that has one independent variable. In this case, because I solve for x2 in terms of x3, x3 is the one that has the freedom to take any value, any real value that I want. So in this case, x3 will be my independent variable. But I could switch it up, so x2 could be my independent variable. The important thing for you to remember is that the number of independent variables is always fixed for in case that you have those. And because of that, because remember s could take any value, this is an example of a consistent system that has infinitely many solutions, because my solutions are going to look like x1 is c1, x2 is minus 7s plus this other fixed number c2, and x3 can be that any given value, fixed value, but you can take any arbitrarily chosen value there. So these are the kind of things that you're going to see for this quiz 3. Other questions that you need to pay attention on how to solve are going to be like, say, if I have 4 equations and 3 unknowns, what are my possibilities? If you see here, I have 3 unknowns and 2 equations. So what can you tell me about the reduced echelon form if I have 4 equations, so 4 rows and 3 unknowns? What can you tell me about that? So these are the kind of things that, again, you want to review, and the connection between the reduced echelon form and the number of solutions that we have for our consistent systems. And finally, you're going to see in module 1.6 at the end, homogeneous systems. Homogeneous systems are when this part, your constants, your b's, were 0. And what happens is, every time that you have a system of equations, say ax1 plus a1, x1 plus a2 x2 plus a3 x3 equals 0, for any homogeneous system of equations, so with zeros here, you always have the solution that is making x1 equals to x2 equals to x3 equals 0. So those are a particular case of consistent systems that will always have at least one solution. And again, using the reduced echelon form, you're going to see when you could have infinitely many solutions, but at least you know that making x1 equals to 0, x2 equals to 0, x3 equals to 0, etc. would be at least a solution. So these are the ideas that I want you to keep an eye on while you're reading for this material. And make sure that you watch the videos. The videos will give you some specific examples on problems like this and ask questions. Thank you.